Hello, in this video I will do some weight-based IV infusion dosage calculation. So yeah, this is this is dosage calculation and we're doing intravenous therapy and we're doing weight-based IV infusion. Okay, so let's just start an example. So example one says we have an order. Hold on. Okay, that's much better. So in example one says we have an order, and I probably won't, I'm not pronouncing this correct, but I'll try my best. Gan Ganciclovir. Um, it's a medication. So it's Ganciclovir. Gan Ganciclovir, and it's 5 milligrams per kilograms IV fusion over 1 hour, uh, every 12 hours. Yeah, Q12H, that's every 12 hours, for 7 days. And the patient weighs exactly 154 pounds. And our availability is granciclovir of 10 milligrams per milliliter. And we have to round our answer to the nearest whole number. And then there's several parts. So let me read the problem again. So we have an order of ganciclovir of 5 milligrams, 5 mg per kilograms, IV fusion over 1 hour every 12 hours for 7 days. And the patient weighs 154 pounds. And our availability of granciclovir, 10 milligrams per milliliter. And we got to round each answers to the nearest whole number. So let's see what part A says. So part A says, how many milligrams should the patient receive per dose? So when you look at your questions, oh yeah, this is how you know your answer is correct. Figure out what is their final unit. It says how many milligrams. So our final unit should be in milligrams, right? How many milligrams? Let me draw. How many milligrams should the patient receive? So our final answer has to be in milligrams. Okay, so what would I do? Um, let's use what so we could start this problem with dimensional analysis, and I'm just gonna just finish it with dimensional analysis. You could do ratio and proportion, but I'm just going to stick with ratio dimensional because it's just much easier and it's just one step, right? So how do I start this problem with dimensional? First, I have to convert. If you look at our problem, every um our order is in kilograms, 5 mg per kilograms, right? So first I have to convert our patient's weight into kilograms. So our patient weight was 54 pounds, so 154 pounds. So we have to convert pounds to kilograms. And that's pretty easy because so the patient weighs 154 pounds and we got to convert that to kilograms. So this is something you must know. You must know that 1 kilogram is exactly 2.2 pounds. That's something you just have to know. If you look at your cheat sheet, it had the conversion from kilograms to pounds. Okay. So what happens is the pounds disappears and then you're left with kilograms. So multiply across, so it's 1 times 154 is 154, and then it's 1 times 2.2, and 154 divided by 2.2 is 70 kilograms. Okay, that's on our answer. Our final answer has to be in milligrams, so we are in kilograms. So what do we do next? Then what I could do is, oops, I hate when this happens. Oops, draw. Then what we have to do is convert that kilograms to milligrams. So how do we do that? Use what you have. So we said that our order glycovir was at 5 mg per 1 kilogram. That was given, right? And then what we could do is multiply that by our new weight in kilograms, 70 kilograms, and you get 5 times 70 is 350 over 1, and then the kilograms disappears and you're left with mg. Now, that's perfectly fine because it's around, we went into the nearest whole number. So our final answer is 350 milligrams. Okay, you could see, I kind of did this by two steps using dimensional analysis. So you could actually do this all in one step. You don't have to actually I prefer to do it all in one step, so you can do it all at once. Okay, so if what how do you do this all at once? You start with their weight. Your patient's weight was 154 pounds, and we're going to convert that to kilograms. So we know that for 1 kilogram, there was exactly 2.2 pounds times, and then our rate was 5 milligrams per kilogram. So you don't have to flip it because the kilograms disappears. And as you can see, if you look closely at our units, the pounds disappears, the kilograms disappears, and you're left with milligrams. That's it. And then you could put all this in the calculator, or you could do it very carefully. Like if you want to show all the steps, it would be 154 times. So you remember multiplying, you do not crisscross, you multiply across. You multiply the numerator then over the denominator. So 154 times 1 times 5. And then on the bottom, it's 1 times 2.2 times 1. And that gives you 770 over 2.2. So what's 770 over 2.2? It is 350 milligrams. Okay, part B. Part B says, what is the IV pump rate in milliliters per hour? Um, you could do this in three methods. You could do dimensional, ratio, and proportion, and the formula method. I'm just going to show you both ways. Okay, so let's start with, so what is the IV pump rate in milliliters per hour? So our final answer has to be in milliliters per hour, or you could say ml completely horizontal like that. Okay, so let's start with dimensional analysis. Okay, so how do we start with this? You start with what we have. So um, So what is the IV pump rate in milliliters per hour? So you take the answer from part A. We started with 350 milligrams over 1 hour. And then we times it by our availability of the drug granular. So our availability of the drug was 10 mg per 1 milliliter. Now, I have to get rid of the mg, so I'm going to flip this. You can flip it, right? So I'm going to put the 1 milliliter on the top and the 10 mg on the bottom. And this will definitely, wait, does that? Yes, that will, our final answer will definitely in milliliters per hour, right? So as you can see, the mg disappears, and then you're left with ml on the top and hours on the bottom. So go ahead and multiply across 350 times 1 over 1 times 10. So 1 times 350 is 350 over 10, and then you have milliliters per hour. And then 350 divided by 10 is 35. The zeros cancels, and you're left with 35 ml per hour. And it says round to the nearest whole number. 35 is rounded to the nearest whole number, so you are good. Okay. So yeah, if you really want to know how to do dimensional, the ratio and proportion is pretty simple. So ratio proportional would be fraction. Um, you could put mg on the top and ml on the bottom. And then over here would be mg and then ml, or you could flip it vice versa. So we know that we were given 1 milliliter per 10 mg, so or 10 mg for 1 milliliter, and we want to know how much milliliters are there in 350 mg, right? And then if you cross multiply, this would be 350 equals to 10x, and then divide this by 10, and you get 35 milliliters per hour. Okay, and then you can also do the formula method. So if you recall, formula is desire over half times vehicle. So desire is 350 mg, and our have was 10 mg times it by our vehicle is ml, 1 milliliter, and you get 35 ml per hour. Okay, part C says how many milligrams is the patient receiving per day? So if you recall in the problem, it said something about Q12H. That was in part of the prop question. What that means is it's every 12 hours. So you're getting meditation every 12 hours. That Q12H means you're getting, every 12 hours. Okay, so you just take the answer from part B. I mean, not part B, from part A. It says how many mg. So in part A, they were asking you how many mg. It was 350 mg. And we're doing this every 12 hours, but how many hours are there in a one day? 24 hours. So 24 divided by 2 is 2. So it's 350 milligrams times it by 2, and you get 700 mg per day. Okay. So how many milligrams is the patient receiving per day? 700 milligrams per day. Okay. Let's do another example. Oh, this one is a little bit strange because it's dealing with complex fractions. So, I will explain complex fraction, a little bit. So, in this example, we have order is for dopamine of 3 mc. So this is how it was written, 3 mc per kilogram per minute. This is also, it can also be expressed like this as a complex fraction, 3 mcg per kilogram per minute IV infusion. Okay, so don't forget about complex fraction. I'll explain. It's really simple how to simplify this, but I would simplify this complex fraction first before I do the problem. So let me just read the problem. Order is for dopamine of 3 mcg per kilogram per minute IV infusion. Patient weighs 118 pounds. Dopamine 400 mg in 250 milliliters D5W is available. Round your answer to the nearest whole number. Okay. So part A says how many mcg per minute should the patient receive? And I'm just going to do this on dimensional analysis. It's so much easier to do dimensional. Ratio, you can do ratio and proportion, but it's a bit more work. I just like to do it all at once. So this is how you know your answer is correct. Whoops. Whoops, I don't know what happened. Hold on. So this is how you know your answer is correct. Your final answer should be in mcg per minute. That's how you know it is correct. If your units aren't correct, that means it's a bit off. Something's off, right? So how do I do this? So if you recall, we start with what we have. We started with 3 mcg per kilogram per minute, right? And then we're going to times this by, so we want it in minutes, mcg per minute. So uh, we have to get rid of the pounds and we have to get rid of the kilograms. So what's the relationship between kilograms and pounds? So you know what? If you want, let's simplify this first. I think that'll make it much easier. This looks strange, right? 3 mcg per kilogram per minute. That's a bit off, right? This is a complex fraction. You just have to know that this is your numerator and this whole thing is your denominator. So what you could do is we should simplify this before we move on. Let's rewrite this. This is the same thing as 3 mcg over kilogram. And then this longer sign means divide. And then it's going to be minutes. And then this has nothing under, right? It's just an invisible one. And what you could do is you can either cross multiply or you could change this divide sign into a multiplication. But if you do so, you have to flip this, right? This one stays the same. And then what you could do is multiply across, right? So what's 3 mcg times 1? It's just 3 mcg. What is kilograms times minute? It is just kilograms times minute. Okay, let's do that. That's going to be much easier now. So yeah, let's do that. So this simplifies as 3 mcg over kilograms per minute. Our goal, our final goal has to be in mcg per minute. If it's not like that, then it's wrong. So looks like I have to get rid of the kilograms, and it looks like I also have to multiply by the patient's weight. The patient weight was 118, right? So I have to get rid of the kilograms and I have to get rid of the weight. So you could multiply by the patient's weight, which is 118 lbs over 1. And then I have to get rid of the because I have to get rid of the pounds and I have to get rid of the kilograms. Do you know the relationship between kilograms and pounds? It's something you should know on your chart or your cheat sheet. Well, we know that for 1 kilogram, there is 2.2 pounds. Okay, that's something you should know. And as you can see, if you look at it very carefully, what happens to the units? The pounds disappears, this kilogram disappears, and then you're left with mcg on the top, and then minutes on the bottom. That's how you know it's right. You could do it slanted or horizontal, it's up to you. And then just multiply the numerator. So 3 times 118 times 1. I'm going to just show every step. And then the bottom is, this is a 1, this is a 1, this is a 2.2. And then if you put it all together, what's 3 times 118 times 1? That's exactly 354. And then what's 1 times 1 times 2.2? 2.2. And then you have mcg per minute. There you go. And then simplify it. What's 354 divided by 2.2? It's exactly 161. If we round to the nearest whole number, it's just fine because it's exactly 161. And then you're left with mcg per minute. You can also write this as 161 mcg, completely horizontal minute, right? So this is fine. This is fine. It's the same thing. Okay, so what made this problem a little bit more strange it was this complex fraction. I simplify the complex fraction first. That'll make your life so much easier. And yeah, and then I knew I had to get mcg per minute, so I multiplied. Once I simplified it, I got this, and I multiplied by the patient's weight, and then I used my conversion because I need to get rid of the pounds and kilograms, so I know that 1 kilogram is exactly 2.2 pounds. Okay, so you're gonna have to be kind of familiar with complex fraction. So the next one is another complex fraction. Let me do this one. So part B, oh, it's the same question but different. Same prop question. They're it's just they're asking you what is the IV pump rate in milliliters per hour, and I'm going to do a dimensional analysis. So our final, this is how you know your answer is correct. Your final answer should be milliliters per hour. Okay, so never forget about the units. So Yeah, how are we going to do this? So what you're going to do is you're going to use the answer for part A, which was 161 mcg per minute. And then we're going to multiply by what we have. Okay. So let's do this dimensional analysis. So start with the answer from part A. Our answer from part A was 161 mcg per minute. And somehow we have to get into milliliters per hour. So how do I do this? So I'm going to multiply. What do I have to do? I have to convert this minute into hours, right? I have to convert this minute to hour and this mcg into milliliters. So what that really means, I have to put the minutes on the top and hours on the bottom, right? That's the only way to get rid of the minutes, and that's the only way to get hours on the bottom. So what do you think? What is the relationship between hours and minutes? Yes. We know that for 1 hour, there's 60 minutes, right? And then somehow we have to convert this mcg into milliliters. So you kind of have to use your conversion rate. Oh, I know. We have to use what we have. So it said dopamine 400 mg in 250 milliliters, right? That was something that was given dopamine 400 mg in 250 milliliters. So yeah, so this was given. It said that 400 mg per in 250 milliliters. Now, can I leave it like that? I'm gonna have to flip it, right? If I want milliliters on the top, I'm gonna have to flip it. So it's gonna be 250 milliliters and then 400 mg on the bottom. Will this work? Not yet. You have milliliters on the top and we have hours on the bottom. That's good. But we still have a problem. We have this mcg. So you're gonna have to use your conversion rate. So you have to use your conversion rate. So we know that for 1 mg, 1 mg, yes, 1 mg, there's exactly 1,000 mcg. Okay, I know it's a bit confusing because now will this work? Let's see. Uh, the minutes disappears, the hours on the bottom, and it doesn't disappear, so that's good. That's what we want. Um, the milliliters is on top, and it doesn't disappear. That's what we want. We want milliliters on the top. We don't want that gone. And what about this mcg? Well, this mg disappears, and then this mcg disappears. So you're good. So that means that on the numerator, you're left with the milliliters, and then on the bottom, you're left with uh, hours, right? Right? If you look at the bottom, our units on the bottom that doesn't disappear is hour, and we want it on the bottom. And then on the numerator, the only unit that survives is milliliters. Good. And then just multiply across. I mean, not across, but like numerator over denominator. So 161 times 60 times 250 times 1. You can also make it, you don't have to make it slanted. You can also put completely horizontal like this ML on the top and then HR on the bottom. It's really up to you. And then on the bottom, it's just, this is a one, so it's 1 times 400 times 1,000. Okay, so this one is a little bit more work, but that's okay because you have all the tools. So on the top, what's 161 times 60 times 250 times 1? That is fairly kind of like a large number. It is 2, 4, 1, 5, and then three zeros. And then on the bottom, what's 1 times 400 times 1,000? That is 4, and then 1, 2, 3, 4, 5, 5 zeros. And then when you put it all together, it's going to be 6.0375 milliliters per hour. Or you can make it horizontal, it's up to you. But the direction said round to the nearest whole number. Six is a whole number. If you look at the neighbor, it's not five and beyond, so it's just going to be 6 milliliters per hour. Okay. Um, yeah, you could do ratio and formula. Okay, I'll show you real quick how to do this doing the ratio and proportion. I don't really like it, but I'll show you real quick. So with ratio and proportion, you first got to convert 160 mcg to mg. Okay, so uh, you would set it up as a fraction like this. That's 400 mg per 250 milliliters. And then this is going to be 0.161 mg, and then our unknown would be milliliters. Okay, as you can see, if you cross multiply, this is going to be 400x, and then this is going to be 250 times 0.161. So what's 250 times 0.161? That's going to be 40.25 divided by 400, and you get 0.1. Do not round this because we round to the very end, right? You do not round this yet. So 0.10, just write it all out, 0.625 milliliters. So this is why I don't like ratio and proportion because uh, you might have you could make a mistake by rounding. If you do it with dimensionals, just all at once, you don't have to worry about you round at the very end. So then what you want to do is we want it in milliliters per hour. So you're going to use that answer, 0.100625 milliliters. And this was per minute. And then we got to convert that into hours. So you're going to have to put minutes on the top and hours on the bottom. So 60 minutes for 1 hour, or 1 hour is still 60 minutes. And that's going to be 0.6 milliliters per hour. And then you can also technically do a formula. How would you do this using formula? Uh, yeah, what you would have to do is we were given 0.16 mg for 400. So you would do, so formula is desire over half times vehicle. Let's see, our desire was 0.161 mg and our have is 400 mg times it by our vehicle, which is 250 milliliters. And that is 0.1 milliliters per minute. And then we got to get rid of that minute, so it's 60 minutes for 1 hour. So that's 0.6 milliliters per hour. Okay, let's do another example. I think this is the last one. So in this one, it says, your 60 kilogram patient has a dopamine 400 mg in 250 ml D5W running at 25 milliliters per hour. How many mcg per kilograms per minute? So this is the same thing as written like this. It's a complex fraction. So mcg slash kg slash minute is the same thing as mcg over kg, longer division sign over minutes is the patient receiving. Round your answer to the nearest whole number. So how many? Okay. So what you need to know on this one is you need to know your units is correct. So so this is how you know your answer is correct. Your final answer has to be M, exactly like this, mcg per kilograms all over minutes. It's the same thing as you can also write as this. You can write it as slanted as mcg over kilograms per minute. Okay. I like this way. You can also write it like this, completely slanted. Okay, so let's start with I'm just going to finish using dimensional analysis. So start with what you have. So we're saying that your 60 kilogram patient dopamine, your 60 kilogram patient has dopamine of 400 mg and 250 milliliters D5W. So what we're going to do is, and it's running at 25 milliliters per hour. So what I'm going to do is start with the 25 milliliters per hour. So 25 milliliters per hour times, and we know that for 1 hour, there's 60 minutes. And then use the other information we're given. So it says a dopamine of 400 mg per 250 milliliters. Um, so what we want to do is we want mcg on the top over kilograms over minutes. So so what that means is we got to put mcg on the top. So how do we do that? You're going to use your conversion. The conversion you need to this wasn't given, but it's something you should know. So if we want mcg on the top, that means we have to get rid of the mg. So you're going to put in mg on the bottom and mcg on the top. So what is the relationship between mg and mcg? For 1 mg, there is exactly 1000 mcg. That's something you have to know. So yeah. And well, so let's see, does this really give us this mcg per kilograms per minute? Um, Let me think. Okay, let's see what cancels. The milliliters disappears, the mg disappears, right? And the hours disappears. What is your units on the top? On the top, you're left with mcg, right? There's nothing else, right? The mcg. And then on the bottom, you're left with minutes. Oh, I see. Okay. Then what we have to do is we have to divide this answer by your patient's weight because we need some kind of kilograms, right? So let's do this first. Yeah, this is like a two-step. I don't think we could do this all at once. So it would be 25 times 1 times 400 times 1,000. And then on the bottom, it's 60 times 250 times 1. And then you're left with mcg over minute. Now, uh, I don't like that. It's like when you do the calculation, you get 600, 666.666. Do not round yet. Just leave it as 0.666 mcg per minute, right? We just proved that when you do the algebra, you're left with mcg per minute, and then we got to divide this by the patient weight. So you're going to divide this by the patient's weight, which is 60 kilograms. So this is a complex fraction. And when you do the algebra, your units should be mcg per kilogram per minute, and I'll show you. So this is a complex fraction. So what you need to know is this whole thing is your numerator, and then this whole thing is your denominator. So you're going to rewrite this as 666.666 mcg per minute divided by 60 kilograms over 1, right? And then what you could do is you can either change this divide sign to multiplication. If you do that, you're going to have to flip this. So it's going to be 1 on the top and 60 kilograms on the bottom. And then this stays the same. So 666.666 mcg over minute. And then when you do the algebra, just look at the units. On the top, you're left with mcg, and then on the bottom, you're left with minutes and kilograms. Now, is that our answer? Yes. I mean, is that our correct units? Yes, because we said that our correct units should be mcg over kilograms per minute. Is that what we got? Yes, mcg per minute. Wait, is that right? mcg per minute divided by kilograms. Yes. Yes. So then you do the algebra, it's 666.666 over 60 kilograms. And when you do the algebra, you're going to get 11, 11 point something, but they went round to the nearest whole number. It's going to be 11. So you're left with mcg per kilograms per minute. Or you can say 11 mcg per kilograms per minute, all slanted like this or like this. Okay, I'm gonna stop here. I'm not gonna do ratio and proportion. It's just more complex. I like it this way, so I'm gonna stop here.